We're continuing with the basics of geometry today, and we'll be discussing angles and their measures. An angle is a figure formed by two rays that have the same initial point. The rays are the sides, and the initial point is the vertex. So here, in this case, point B is your vertex. And then rays BA and BC come out from the vertex to form the angle. There are a couple of different ways that we can name this angle. We can call it angle, and this is the symbol for angle. This little looks like an L that you've leaned on a little bit. Angle ABC or angle CBA. Keep in mind the vertex must be the middle letter. All right, so now let's move on. In this picture, we want to name all of the angles here that we see. Well, for starters, we see angle STR, so let's write that down. We see angle STP, and we also see angle RTP. All right, now PTR would be another name for RTP. PTS you could use for angle STP, and RTS you could use for STR. So either way you look at those, there's a couple of ways to name these angles. So let's move on. Now, if you want to talk about the measure of an angle, the way we say the measure of angle A is M with our little angle symbol and A. Now, the next thing we want to do is we want to talk about how to measure and draw angles. So what I'm going to do is I'm just going to draw some angles right up here. I'm just going to put this one right here like so. And I'd like to find the measure of that. So I'm going to take my protractor. I have a protractor tool here. And I'm going to move it. I'm going to point to this part. This point here, right in the center at the bottom of the protractor, is going to go right over the vertex. So I'm going to drag that so it goes over the vertex. And my line lines up with the line on the bottom of the protractor. It lines up with 0 and 180. Now, whichever line on the protractor has the smallest number, so in this case it's 0, that's on the inside, I'm going to read on that inside line going up. So you look at 0 and 180, which one's smaller? 0, so you're going to read from that line. And so what do we get for a measure? Well, it looks like we go to about, it's a little after 65, about maybe 66 degrees. Okay, so now let's say that we draw another angle here and measure it. I'm going to draw this angle. So I'm going to take my protractor. So I've drawn it in a little bit different position. I'm going to drag it down, put the center there on the bottom where those lines intersect, right on the vertex. I have to move it just a little bit. There we go. Now, I'm probably going to have to rotate this a little bit to get it to line up, and so let's do that. So I want to line it up. I think I've just about got it. There we go. All right, so now I've lined it up here on this side of my angle on the left side. I want to look at the numbers here. My numbers are 0 and 180. Start from the line that has the smallest number. Well, that's 0. This time it's on the outside, so I'm going to read around to the outside till it hits the next angle. And so right here we can see that this goes around to about 129 degrees. So if it hits the other side of the angle here, it's not quite to 130, it seems to be at 129. Again, we're reading from the outside. Okay? Now, let's say that I asked you to draw a, let's say, 43-degree angle. All right? Now, first thing you're going to do is you're going to draw a straight line. You're going to put an arrow on the end of it. Notice that I have arrows on the ends of my angles, sides of the angles, because they're rays. Okay. Now I'm going to take my protractor and I'm going to put it on the end of that line. I'm going to line up the center, the bottom of the protractor, the end of that line where those two lines on the protractor intersect. And I've lined it up on the right-hand side. So I'm going to start reading from the side, from the line with the smallest number. 0 is on the inside, 180 is on the outside, 0 is smaller, so I'm going to read from 0 on until I get to 43 degrees. Well, here's 40, and I need to go about 3 places past that. So I'm going to make a mark. Let's see if I can get it to show up. There we go. And now I'm going to draw a line to that mark from the center out to 43 degrees. There you go. So I've made a 43-degree angle. Okay, so let's move on. The interior of an angle, here's a definition. Interior is located between the two sides of the angle, and the exterior is located outside the two sides of an angle. So for instance, if I were to draw this angle here, this point, say here, is in the interior. That's between the two sides of the angle. And if I made a point here, this is the exterior, this is outside the two sides of the angle. So we'll go back so you can still see that. Okay, so now let's move on to the next page. The next thing we're going to be talking about is the angle addition postulate. And what it says is if P is in the interior of angle RST, then the measure of angle RSP plus the measure of angle PST equals the measure of angle RST. And let's just draw a picture of what this could possibly look like. We're going to make an angle here. And I'm going to have this point P. This is angle RST. And P is in the interior. Now what I'm going to do is I'm going to draw a ray from S through point P. And now what I've actually illustrated here in this drawing is that if I were to add the measure of angle RSP to the measure of angle PST, I would get the measure of this big angle RST. Now, some other definitions. An acute angle is less than 90 degrees. A right angle is exactly 90. An obtuse angle is greater than 90 degrees and less than 180. And a straight angle is exactly 180 degrees. Adjacent angles are angles that share a vertex and a side, but no interior points. So in other words, they are next to each other. So for instance, adjacent angles in this case would be angle STR and angle RTP. They're adjacent. They share a vertex and a side. Okay? So both of these angles share the side RT, so that makes them adjacent. They're basically joined to one another. So we'll say angle STR and RTP are adjacent angles. Let's move on. Okay, so we're given this problem. B is in the interior of angle AOC. So right off, I am going to draw this angle AOC. Now this is not going to be drawn to scale by any means. So here's A, O, and C. And B is somewhere here in the interior. We don't know where, it's just in the interior. Now it says C is in the interior of angle BOD. So what I'm going to have to do is draw a ray from O through B. And now it says that C is in the interior of BOD. So I'm going to have to also draw D somewhere out here. So let's say I put it here. I'm going to have to draw a line from O through D. We'll label it. Now it says that D is in the interior of COE. So let's CO and then E will have to come somewhere out here. So I'm going to make E. And I'm going to have to draw another ray from O through E. Again, keep in mind this is not drawn to scale. If it turns out that way, it's a complete surprise. So now let's see what the information is that we're given. We're given that the measure of angle AOE is 175 degrees. So this is the measure of this whole angle here is 175 degrees. The measure of angle COE, so this part right here, is 110 degrees. Okay, so you can already see it's not drawn to scale. We also know that the measure of angle AOB, COD, and DOE are equal. They're all the same. So AOB, COD, and DOE are all equal. And so we would like to find the measure of DOE, BOC, and AOB. Well, first of all, we know that COE is 110 degrees. We know by the angle addition postulate that COD and DOE have to add up to 110. If they're both equal, we would take 110 and divide it by 2. So each of these angles would end up being 55 degrees. That has the same angle measure as AOB, so that would also be 55. So let's write down what we know so far. We know the measure of angle DOE, which we were asked for, is 55. We also know the measure of angle AOB, which was 55. Now we're asked to find the measure of angle BOC. Now we know that all four of these angles here add up to 175, and we've got three of them. Three of them are 55 degrees apiece. So if we have 55, 55, and 55, and we add all of those together, we get 165 degrees. Well, all four of those angles add up to 165. So if we want to find out how much is left over for that fourth angle, measure of angle BOC, we're going to have to take 175 minus 165. So the measure of angle BOC is 10 degrees. So there is our missing angle. Thank you very much for joining me today.